Welcome to LabVIEW Ability Enhancement Lab. In this video, we are going to demonstrate Boolean operations. As we are performing Boolean operations, we need Boolean controllers and Boolean indicators. Right-click on the front panel. As we are performing Boolean operation, we have to consider Boolean input. Click on Boolean, select push button, place it on front panel, rename it as input A. Similarly, select second Boolean input, Boolean, push button, place it on front panel, rename it as B. Corresponding graphical icon will be represented on the block diagram. Next, we have to select Boolean indicator. Right click on the front panel, select Boolean, in that select round LED. Place it on the front panel, rename it as AND gate. Similarly, select Boolean, round LED, place it on front panel, rename it as OR gate. Right click, Boolean, select round LED, place it on front panel, rename it as NOT gate. Similarly, select Boolean, in that select round LED, place it on front panel, rename it as XOR. Right click on front panel, select Boolean, in that select round LED, place it on front panel, rename it as NAND. Next, we need Boolean operators. We have to select Boolean operators on the block diagram. By right clicking on the block diagram, select Boolean, in that select AND gate, place it on the block diagram. Similarly, go to Boolean, select OR gate, place it on block diagram. Similarly, select NOT gate. Again, right click on block diagram, select Boolean, in that select exclusive OR gate, place it on the block diagram. Right click on block diagram, select Boolean, in that select NOT followed by AND, which represent NAND gate. Now we are having all the 5 operators which are placed on the block diagram. Let's label each of the gate. Right click on the gate, select visible item, select label, so that it is going to give the name of the gate on top of each of the gate. Right click on the gate, select visible item, then select label. So now we are having all the 5 gates with its corresponding name: AND, OR, NOT, exclusive OR. Last one is NOT followed by AND. Next, we'll make the connection of each of the operator. One of the input of AND gate is connected to input A. One of the input of OR gate is connected to input A. NOT gate is connected to input A. One of the input of exclusive OR gate is connected to input A. Similarly, one of the input of NAND gate is connected to input A. All the 5 gates, one of the input is connected to input A. Let's align the icons properly. For alignment, click on the icon, drag it to till where we want to place, and leave the icon. Next, let's make the second input connection. Select second input of AND gate and connect it to input B. Then select second input of OR gate and connect it to input B. As we are having single input to the NOT gate, no need to make connection. Then select second input of XOR gate to the input B. Second input of NAND gate to the input B. So all the gates input has been connected. Next, let's make the output connection. AND gate output to the AND LED, OR gate output to the OR LED, NOT gate output to the NOT LED, exclusive OR gate output to the XOR LED, NAND gate output to the NAND LED. Let's save the VI. Click on the file, go to save. In that, give the file name as Boolean. Then click on OK, so that we can able to save the VI. Before checking the output, let's see the truth table of all the gates. If we consider NOT gate, it is having a single input. When the input is 0, the output will be 1. If the input is 1, the corresponding output of NOT gate will be 0. Next, considering the AND gate, we'll be having two inputs. If both the inputs are 0, output will be 0. And if any of the one input is 0, the output will be 0. Only if all the inputs are logical 1, then the output will be 1. Next, considering NAND gate, it's the complement of AND gate. If any of the one input is logical 0, the output will be 1. If all the inputs are logical 1, then the output will be 0. Next, let's consider OR gate. We'll be having two inputs. If any of the one input is logical 1, then the output will be 1. If all the inputs are logical 0, then the output will be 0. Next, we'll consider XOR gate, that is exclusive OR gate. We'll be having two inputs. If both the inputs are having equal values, if both the inputs are 0 or if both the inputs are 1, then the output will be logical 0. If both the inputs are unequal, if one of the input is 0 and other one is 1, then the output of the XOR gate will be logical 1. Let's run the VI. Considering the Boolean inputs A and B as 0, the corresponding output of AND gate is 0, OR gate is 0, NOT gate is 1, XOR gate is 0, and NAND gate is 1. Next, if we change the input combination as A is equal to 1, B as 0, as per the truth table, the output of AND gate is 0, OR gate is 1, NOT gate is 0, XOR gate is 1, and NAND gate is 1. Next, if we consider both the Boolean inputs as logic 1, then the corresponding output will be AND gate output is 1, OR gate output is logic high, NOT gate output is logical 0, XOR gate is low, NAND gate output is 0. In this way, we can able to check all the possible input combination and the corresponding output of each of the gate.